So today we are going to begin with object-oriented programming. Okay, so before defining what object-oriented programming, or sometimes even called OOPS, we are going to understand certain concepts regarding this, and then I'm going to give you the definition of every concept that we have learned over here. So first of all, we have to understand what is object-oriented programming. Now, before getting into the nitgits of this particular style of programming, so far whatever programming you have done is structured programming. Let me be very clear. That is called structured programming. Currently, from class 9 onwards, you will be learning something called the object-oriented programming. Though at the very initial level, you might think it is almost similar to whatever you have learned previous to it. In the sense that in the classes prior to this class. However, slowly you will understand that the style of programming will be slightly different compared to whatever you have learned before this. Before understanding what is object-oriented programming, there are certain concepts which you need to understand. The first concept that I am going to give you is objects. Let me tell you what is the meaning of objects. Object is anything. Anything is an object. This pen is an object, this board is an object, there are lights over here in this particular room, even in your room, the lights are there, even that's an object. This pen which I am holding out here, even this is an object, me, you, everything is an object. So anything, any physical quantity which you see over here, or physical matter which you see over here is an object. Now, how is it related to coding? Now you see, what it has been seen is we are trying to imitate the real world objects as programming world objects. That is the basic relation we are trying to create. To create software which are, quite, near to realistic world. So this is what we are trying to do. Hence, so many different styles or concepts of programming. First of all, we'll begin with objects. Objects is anything that has certain characteristics and behavior. Characteristics means what are the features in it. For example, I have this pen over here. You can see this pen, it has a cap, and the cap has a black strip over here, and there are a lot of things written out here. It's white, mostly in color. And what is the behavior? We use it for writing, we use it for drawing on the board, you may also use it for poking. I'm just kidding, you please don't do that with your friends. But this is what we do when I talk about having a certain behavior. So every object in this world has certain characteristics, that is physical features, and then behavior. What is the use of that? So every feature or every characteristic has a certain behavioral aspect associated with it. So that is what an object is. So currently we'll start defining the objects. But before that, so this is what objects are, which has certain characteristics and behavior. Now I'm going to talk about certain principles which are related to object-oriented programming. So the first principle related to this is encapsulation. The second point is abstraction. The third point is polymorphism. And the fourth point is inheritance. So these concepts are present in, or they are called the principles or features of object-oriented programming. So we are going to understand each one of these concepts. Very simple, and after that later on I am going to give you the definition for each one of this. You have to by heart those definitions. You see, ICSE question paper will be slightly different from whatever you have learned so far. Here the question paper is of 100 marks, and then it has been divided into two sections, section A and section B. Section A consists of 40 marks and section B consists of 60 marks. Section A consists of theoretical aspects of Java, both question answers as well as short questions related to programming. You need to understand, very deeply programming concepts. Only then you will be able to solve section A. And section B is altogether programming. There will be 6 questions, 6 programming questions, out of which you have to solve 4 questions, each consisting of 15 marks. So getting back to this object-oriented programming principles, so the first principle which we have is encapsulation. The word itself, tells everything. Encapsulation means that a kind of a capsule or a protective layering. You must have seen a physical capsule. I'm talking about the medicine capsule. You must have seen it. So what does it contain? It contains medicines inside it. So why on earth did they put a protective covering on top of it? Because this particular medicines can easily disintegrate if you bring it to air. Or in other words, if you bring this medicine is kept without a capsule, without a protective covering, once you open it from the cover, what will happen is it will start disintegrating. So that is why it is kept inside a protective covering called capsule. And this capsule will not disintegrate so easily. What will happen is when you have this capsule which contains the medicine inside it, only through the enzymes of your stomach, this particular medicine gets digested inside your stomach. So encapsulation doesn't mean just simply a protective covering. It also means that there are certain places where this covering will be used, or there will be places where it will allow you to access the internal content. So in our case, when we have the medicine capsule, it is only through the digestive enzymes in our stomach it is possible for the medicine to be absorbed into the stomach. So this is what happens with encapsulation. That means encapsulation means protective covering. This is essential when it comes to programming which involves security. So this is the first aspect of object-oriented programming. The next comes abstraction. Abstraction means hiding the complexity and giving a very, very simple interface. What do I mean by that? Hiding the complexity. For example, you must have seen a switchboard. You must have seen a switchboard in your room. What does the switchboard contain? It contains certain number of switches and a socket. These switches are responsible for starting a particular appliance. You must have seen it in your home or in your school. There are certain switch, either way from the left side or from the right side, which you have already known or which you already identify, which is going to start a particular appliance. For example, the second switch from the left will start the fan. You already know this. Now imagine this switchboard wasn't there. What would have happened? You would have, got a group of wires hanging at the side of your wall. Imagine a situation where there is no concept of switchboard. What would have happened? You would have seen that at the side of the wall there is a huge group of wires coming out. And to start a particular appliance, you would need to join 2 wires to start a particular appliance. This you would have done. And this could be quite fatal because you might get a shock event. So that is why, a very interesting concept has been used. What they did was, in the sense that the electricians, what they did was, they created a switchboard, and each of this pair of wires, which, starts a particular appliance, this is connected to a switch. And only when you apply this switch, that means when you switch it on, only then the particular appliance gets switched on. So this is what happens, what is called abstraction. Abstraction means the entire switchboard is an abstraction. Is an abstraction in the sense that all the complexity of the wires inside, that means a group of wires which is going to start which particular appliance, is completely hidden from the user. So you see, the entire concept of this, wires, you don't need to know, because again, get back to the example which I was telling previous to this. Suppose, say for example, you don't have this concept of switchboard. You will have, got a lot of wires, hanging from the wall. During the initial days, you could easily, connect 2 wires to start a particular appliance. But after a few days, these wires would have got entangled further, and it would be more and more difficult, to start a particular appliance. So this entire complexity is kept now hidden inside a box. And you get a very simple interface. That means you are not aware Even if you see the wires coming out of the switchboard, you will not be aware which particular wire is connected to which particular appliance. So the entire complexity you don't need to think. I can give you one more example. For example, I drive my bike, I drive my car. You see, I drive both this type of vehicles, but I have no idea how internally this particular system or this particular engine works. How it moves the wheel, how do I make it slow, how do I make it fast. The internal structure, how it works, I have no idea. I only know how to ride. This particular system is going to increase the speed of the vehicle, this is going to decrease the speed, this is where I apply the brake, but how it is stopping the internal complexity, I have no idea, because it is built in such a way so that you get a very simple interface. You don't need to worry about that. Those worrying is done by engineers. So that is what the concept of abstraction is. And remember something, it is through encapsulation that abstraction is obtained. Remember the encapsulation which I talked about. Encapsulation is giving a protective covering. Now get back to the example which I already said. We have a switchboard and a protective covering is given on top of it with certain number of switches. So what happens is the entire complexity is kept hidden completely. So encapsulation is the process through which we get abstraction. So abstraction is simply an idea for hiding all the complexity. And how do we do that? With the help of encapsulation. So they are even related to each other. Next comes polymorphism. Now poly means many and morphisms means form. It means that it is the ability of a function to remain in different forms. Okay, I might be sounding Hebrew or Greek. Let me give you a very simple example of polymorphism. What happens? Suppose, say for example, you have a room. You have a room and you have three highly unlikely animals inside the room. That is a cat, a dog and a rat. So these three cats, these three animals rather, are not very good friends among themselves. So these are three animals which we have kept inside the room, say, highly unlikely animals which will remain inside the room. And now we also have a balloon, kept inside the room. Now, because of some reason or the other, the balloon burst. It burst like a cracker, a huge sound. Now you see the behavior. What the rat does is, once it hears this huge loud sound, it just starts, running and trying to find out a hole just near it, just to hide, because he thinks that, something is attacking it, so therefore it has to hide. So that is what the behavior of the rat will be. When it comes to the cat are least bothered. They might be yawning or, licking their paw. They are always trying to keep themselves clean. They are hardly bothered, maybe a small, sound they may be emitting and only that much. They might hardly be bothered with the sound, or maybe even if they are bothered, once they find out what actually happened, they won't, keep on, lurking with that particular problem. So that is how the cat behaves. Now when it comes to the dog, dogs are dogs and it will start barking and it might not stop also. You must have seen those street dogs, they continuously bark. So same thing might be happening over here. Anything which is, not proper, it will start barking over here. So in this case, the dog starts barking continuously. So now you see what actually happens. For the same bursting of the balloon, what actually happens? The three animals behave completely in a different way. So this is what polymorphism is. So this is what we are going to learn with respect to programming. Slowly we are going to do this. Next comes inheritance. You must be knowing what inheritance is. You have studied in biology, I believe. Inheritance basically, when it comes to biology, it means, a certain characteristic or traits which you inherit from your parents. So exactly the same thing happens over here. We inherit certain characteristics or certain behavior from certain programs and recreate or add more functionalities to it to create a new program. This is what happens with the, different type of programs. You must have seen the versions, different versions, version 1, version 2 or version 2.5 or higher versions. What actually happens is they use the same software. They add, what they do is they inherit this particular same software or the same program, add additional features to it and release it in the form of a new version. So this is what happens with inheritance. During yesteryears, this used to be a big problem to bring out the second version of a particular software, because it used to consume a lot of time, because they never used object-oriented programming. They used structured programming, where every program which you need to be developed from scratch. That is from the beginning. Whereas with object-oriented programming, we have the capability of extending the functionality of a particular software package. So that is why the object-oriented programming is very, very relevant. And we are going to learn the language Java, which is completely object-oriented programming language. So it's a OOP language, Java, and it has all the features which we had learned over here. And in fact, we will be learning programming with respect to applying all these principles. And you'll get the definition of each one of this in the file below. Now, what we are going to do is we are going to learn two concepts. One is called the class, one is called object. Of course, related to object-oriented programming. Now, by definition, class is a method of creating an object. In other words, class is a mechanism to create encapsulation. Now, a bit weird. Let me give you an example. For example, you must be, having some kind of book. Say you have a computer application book. Now, there might be several students having the same book. Do you think that particular author has written separately for every student? No, naturally not. What he or she has done is, he or she has created just one copy of that particular book, and multiple books were created from that single copy in the form of printing or offset machines. These days they use for creating multiple books. However, the main book is simply one. So what actually happens over here is only one book is created from where multiple books are being created. So that one particular book, we'll call it a class. And from there, multiple copies of books which were created, we'll call it objects. So from a class, you get several objects. Object 1, object 2, object 3. There might be several objects. And each of these objects will be having the same characteristics and features and behavior as defined by the class. So that means class acts as a template. For example, you get a form. You get a form for some kind of, admission or whatever you call it. And all of you are going to fill up that particular form. Now what actually happens is, all of you get the same form because only one form was created, and that form is called a class. And multiple forms were created. Each of these forms are called objects. Now what do we do with each of these forms? We fill up with our names. Say in a form of this particular person, he writes his own name, say X. Another person out here will be writing his own name, that is Y. Some other person will write their own name, say for example Z. But the format or the structure of the form is exactly same. So the objects, although they are structurally or physically they are same, but their content is different. So the content of an object is called the state of an object. State of an object. So state of an object will always be different, or it may even be same, but it's a unique feature of an object that characteristically distinguishes between two objects. Although there may be more than one objects which are identical to each other, but they will still be different from each other. One, because of the physical features it has. The next one is the state of an object. So in other words, state of an object means the content of that particular object. So this is the concept of class and object. So class is simply a template or a main form, you can imagine it. And objects are multiple copies of that particular form. So from one particular template or from one particular blueprint or skeleton, multiple copies were created. We call it objects. So that's the concept of class and objects. Next, what we are going to do is we are going to understand what we are going to learn when it comes to the programming part. We are going to learn the language called Java, which is obviously object-oriented programming language. But before getting into the details, Java is very unique. It's extraordinary compared to the languages which you have learned before. Some of you have already started with Java in your school, but we'll be learning the different features of this particular language, which is very essential to understand how this particular language works. It is simply not just another language which you're going to learn with a slightly different syntax, but it has certain unique feature. Now, when it comes to programming, what is programming? Programming means giving a set of instruction to the computer to do a particular job. This is what programming is. You have been learning this since a long time. Giving a set of instruction. For giving a set of instruction, you naturally require a language. When it comes to computer, you require a computer language. So Java is such a computer language. Now, this particular language which you use needs to be converted to a language which the computer understands. This is the job of a translator software. So, just simply writing a program in a particular language is not enough. What we need to do is, we need to convert it to a language which the computer understands. Yes, some of you must be thinking about machine language, but it is not always the machine language. That is why what I am trying to tell you out here is to a language which the machine understands. We are going to get into those concepts later, but first of all, let's see how it works. So, first of all, we have the program which we have written. We call it the source code, remember? Source code. This is the program which you write. And then we are going to translate it to a machine understandable language. After translation, we'll be able to execute it. So, there are three steps rather. So, the first step is writing the program, that is the source code. Next, second, the translation process. And lastly, what do we have? The execution process. That is, we are going to make the program run. That is, make it do whatever we have asked it to do. That means we are telling that we have given a set of instruction. We want the program to work according to the set of instruction that the user has given. Or in other words, whatever instruction you have given in the source code, it's going to start executing that. So these three features are there in every programming language. Now, to do this, basically during yesteryears, we required, three different software. So three different software was required. You require an entire bundle of software package to perform these three different operations, which used to consume a lot of time. So what the great scientists, they have thought of having a single software which will have features for writing the source code, obviously writing the program, in other words, the process of translation, that is to convert the entire source code to a language which the machine understands, and then there is a process for executing that particular source code. So this entire three essential features are bundled into a single software. And this particular software is called IDE. IDE stands for Integrated Development Environment. Integrated Development Environment. So, Integrated Development Environment or IDE is used to write the source code, to perform the translation process and the process of execution. So these three unique things needs to be performed using a single software which is called IDE. And there are several IDEs which are available for Java, which is made by different companies. So what are the names of this? The first one is NetBeans, very famous because it's created by the same company as Java. The other one is Eclipse. This is open source. However, it was created by IBM initially. There are others even. We have IntelliJ IDEA. But we will be using BlueJ. BlueJ, why do we use this? First of all, of course, it is recommended by the board. We'll be using BlueJ. That's an IDE. And BlueJ doesn't stand for Blue Java or anything of that sort. You are not going to learn a Java which is blue in color or anything of that sort. The name of the IDE is BlueJ. That's it. And inside that you will be writing the same Java program had you used Eclipse software or NetBeans software. The IDE is different and each of this IDE has different features. But for professional development, BlueJ is not good enough. Let me be very frank with you. It is for understanding the different concepts of object-oriented programming through Java. So BlueJ is the easiest environment of understanding object-oriented programming with respect to Java. That is why even the board has thought about applying the BlueJ IDE. NetBeans is highly professional for NetBeans and as well as Eclipse is used by professionals. And it has so many features that you will require an entire course to understand the different options in the IDE itself. So the question arises whether you are going to learn how to program with Java or you are going to learn the different features which is offered by the IDE. That is why the board has kept software which is very simple in usage, that is BlueJ. Okay, so now what I'm going to do is before beginning with the programming style of Java, we are going to learn how to use BlueJ. So the next part of the video will show you how to use BlueJ. Using the BlueJ, so there we have the BlueJ icon on the desktop. You can simply double click on it to start with the BlueJ. That's the splash screen, initial screen. That's called a splash screen. And here we begin, and here what do we have? The first option is project. Project in terms of BlueJ means creating a folder, and that's the way, a unique technique of BlueJ to force you to create your own folder where all your programs will get stored. And remember, programs in Java are called class. So here we are going to create class, and this group of classes will be kept inside a folder which we call a project. So click on project, new project, and it gives me a new dialog box named new project. So here let me start with the first project. Let me give this name first project. First project, and I am trying that in the E drive. That's the location. You may click on the choose button to start with something else, and then we are going to click on OK once this is done. Okay, that's it. You can see the screen has got activated. It's more white in color, indicating that it's active and it's ready to accept commands. Now what we are going to do is we are going to click on new class option. So let's click on new class option. Okay, let me start with this. Let me give the name first. For the name of the class, ensure that the radio button, this is active, that is class type. So many different options are there. Ensure that you are on the class option, and remember the class language is Java. That will be ticked by default, and click on the OK button. And remember, there cannot be any space between the class name. So keep that in mind. And here what happens is the first program named first is created. You might wonder that what is inside this program. You see, BlueJ has the habit of creating a dummy program whenever you click on the new class. The program is completely correct but does nothing. That's the irony of it. So let me double click over here, and this will open that particular program. You can see this is the editor window where we are supposed to write our program. So here you can see a few comments are there. We'll come across that later. What we're going to do is from this particular part till the end, we can simply remove it. I'm leaving the closing brace for the class. You can see the closing brace, I've left it because that will be required, and remaining part I'm going to remove it. So we are left only with this. You must have noted how I highlighted the entire text in the program, and then I press the delete button on the keyboard to remove it. Now we'll begin with the program. So what do? We simply write a simple program that is going to display a message, say hello. So we'll begin with static void main, and we begin with the opening brace, and here let me give the message. Remember, we use system.out.print. We'll give a message, hello from Java, and we'll end with a semicolon and then the closing brace. That's it. That's the entire program. Now what we are going to do is we are going to click on the compile button. Let's click on the compile button, and here you can see at the bottom of the screen, see over there, class compiled, no syntax error. That's the message which you are going to get. If there is no error, in case there is an error, it is going to display that particular error over here, and that particular line will get highlighted over here. Now what you do is you click onto the close button. Now you see initially there were strips over here, and now after you compile it, and if it is 100% correct, that is without any syntax error, it will be plain like this. So now what we are going to do is right click on it. Let's right click. That's the right click. And here you can see the function void main. That is what we had written after static. We had given the name of the function as void main. So now what we are going to do is you can simply click over here, and that's the terminal window which is showing our output, that is hello from Java. Let me tell you, this is the input bar. Remember, whenever we are going to give or we are going to make Java program take some user input using scanner, this input bar will be used for doing the input. So don't expect the cursor to be out here. Instead, the cursor will be at the bottom of that particular window. So please keep that in mind while doing any input. Now once you are satisfied with the output, you can simply click on the close button to get back over here. You can once again double click over here and make some changes in case you want. However, you need to remember that you have to click onto the compile button, and if you don't require it, you can click onto the close button. That's it. That is how simply we can do programs or codings in BlueJ.